It's a pleasure and an honor to welcome you to the podium. Gil Levine, everyone.
Thank you very much. You know, President Obama went out to JPL to congratulate the Curiosity team upon their splendid victory of landing safely on Mars, an incredible job. He asked, however, that even though he was very busy, if they detected life, he wanted to know right away. No matter how many things he had on his plate, he'd make room for that. So, I wrote him right away, telling him that here's a summary of the evidence that I and my co-experimenter, Dr. Patricia Strack, got for living microbes on Mars in 1976. I have received no answer. My letter, no doubt, being lost in the torrent of mail dumped on the White House daily. So I'm very pleased to be here in Washington, D.C., hoping that my message may now penetrate to the nearby White House to satisfy the President's concern. I'd like Pat Strack to stand up. She's out there. Pat? I hired Pat as a biochemist, and she was an excellent one, but she also turned out to be a great instrument engineer, solving problems that would have prevented the labeled release life detection experiment ever from getting aboard the Viking mission to Mars. Well, it's been 37 years, and some of you may have forgotten or never even heard of Viking and the labeled release test. It was not mentioned very much on charts of accomplishments of Martian findings yesterday. The Viking labeled release experiment is extremely simple, so much so that some people have called it elegant. However, it's really just based on the standard method to detect microbial contamination. The method used by public health departments in every state in the United States, by the U.S. Public Health Service, and by almost all governments abroad. It's been used since Viking for many decades. It's still used today. It's so good. Very simple. Suspected material is placed into a sterile solution of nutrient in a test tube and incubated. If there's something in there alive and metabolizing, bubbles of gas appear, and that's the evidence for the presence of life. What the LR did was add additional nutrients to the standard method solution in case Martian bugs like something different than Earth bugs. And the trick was we tagged the nutrients with carbon-14 to make them radioactive and to make that gas coming out readily detected by its rising through the soil and going to a radiation detector, long before bubbles would ever form. In fact, the LR, I don't understand the concern, because the LR test is merely the standard method augmented with additional simple nutrients, each of which nutrients is a product of Miller-Urey experiments, products which were thought to have been on the ancient Earth and incorporated into life, and indeed each one of those nutrients is metabolized by living microorganisms. But that wasn't enough for us. Mars is far away, and we knew there would be challenges. So we added a control to the experiment. And I learned in school that the control is the most important part of any experiment. And what we did, and the standard method does not have a control, what we added was if in the rare event we got a positive response, something gave off radioactive gas, we would take a duplicate sample of the same soil and heat it to a temperature which would kill microorganisms. At least it killed all microorganisms we could test on Earth, but not so high as to destroy any chemical that may have caused an oxidative reaction and given us a false positive. So, if we get a positive response, we immediately run a control. If the control is negative, that says it was not a chemical, it was living microorganisms that were metabolizing and were detected and were killed by the heating. A positive control, however, would indicate it was not microorganisms, but was chemistry in some way. Now, I don't want to short shrift this experiment. It was tested thousands of times by Pat and our staff on soils from all over the world. We took it to rare places, including the Death Valley, where there's practically no water, and it readily detected microorganisms. It detected microorganisms in the soil sent to us from the Atacama Desert, even though it only rains every 10 or 20 years there. But amongst these thousands of tests, we never had a single false positive or false negative. It is the most highly tested experiment and instrument ever sent to Mars. I am certain of that. Now, in addition, the Viking data are the only pristine data we will ever have for looking for life on Mars. Why? The Viking spacecraft was sterilized, heat sterilized, at a cost of $250 million, 1/4 of the entire budget of the project. And no spacecraft has ever been sterilized again, with some 18 or 20 of them on the planet and ranging all over the planet. I assure you that anybody who goes there and finds microorganisms will immediately encounter what poor Dave McKay encountered. This is contamination. These are bugs that hitchhiked from Earth. If I can get the slide. This is the label release experiment. As you see, it's very simple. A small portion of Martian soil is fed a very small dose of the nutrient. Gas comes up and is detected. And it was run under Martian conditions, except the temperature was 7 to 10 degrees. We didn't want it to be freezing. And the temperature on Mars goes up to 7 to 10 degrees, so that was okay. We pressurized it to 85 millibars to make sure it wouldn't boil. We didn't really know what the indigenous temperature on Mars was. Lo and behold, we were astounded. The first thing that happened was we got a positive result as soon as we injected the nutrient. We held our breath and watched it for the 7 days. Sol was a day of the experiment, and then trembled while we went for the control. We shot the control, and lo and behold, zilch. There was no response. Right then, we could have packed our bags and gone home. This was proof of life as had been accepted prior to the mission by the scientists, including the NASA scientists involved in the program. But nothing ever happens that similar. Even though 4,000 miles away, we got similar responses. And even though on Earth, in Antarctic soil, we got these identical responses. And in some other soils, these responses, yielding about 10 to 15,000 counts per minute, you couldn't tell them from terrestrial responses. So the data were extremely compelling, but not accepted. Now, I'll tell you why they weren't accepted, but wouldn't you think, as taught in every first year of science class, that when you get a positive response from an experiment that's testing a hypothesis, what you do is go back and confirm that response, and then you expand on that technological beachhead. However, for the 37 years since Viking, no life detection experiment has ever been sent to Mars. We pleaded incessantly to send the LR experiment back, and we even changed the LR to make it more definitive to satisfy those who didn't believe. But no. Many challenges were raised against the LR. All kinds of experiments were run, theories were cited. None satisfied the findings of the LR on Mars, because in addition to getting this control at 160 degrees, we decided to look further. We lowered the temperature of the control, and what we actually found is that when we took the Martian sample in the Viking distribution box and just held it there in the dark, isolated from its environment at 7 to 12 degrees centigrade for 2 months, it became completely inactive. Now, it would be a strange oxidant that behaved in that way, but it sure sounds like it could be a bug divorced from its environment and life cycle that died. But the ultimate challenges that were leveled against us was that there is no liquid water on Mars, no liquid water, no life, and that Mars is covered with a strong oxidant that destroys organic matter, including life. And finally, the instrument on Viking sent to identify, not find, but identify organic matter, which all of us knew was present, just like it's present on Earth, coming in from the sky and from no place else, reported 0 organics. And so the decision was 0 organics, no life, life with 0 organics, and it was conservative to come down on the side of no life. There's some strange chemistry going on in the soil. However, we showed over the years that that was not so. And we beat back every threat that came to explain away our data. But I'm now going to address these 3 major roles: no liquid water, strong oxidant, no organics, with respect to curiosity, which is playing an important role in each. I published a paper in which I said, while Curiosity has no life detection experiment, I think it has stealth life detectors. It will detect organics which are needed. And what we find to support, first, the LR results from what we've learned since Viking on Earth, as Penny has pointed out, you can't go any place on this planet, in a cave, down under the sea, up in the sky, without finding life. Life has completely invaded this planet and conquered it. At the time of Viking, we were told life is a thin film, very delicate on the surface of the Earth and can easily be destroyed. You can set off a dozen atom bombs, you'll wipe us all out, but life will survive. This year, Andy Schroeder from the University of Florida published a paper about Earth organisms which live under Martian environment. He tried them, and a common organism in our spit is Serratia liquefaciens, and he found that it survived and grew under Martian conditions. Also, lichen, which are called the pioneers of vegetation, were subjected to the same atmospheric temperature, radiation, and pressure conditions as they would experience if they were on the Martian surface. They adapted to the artificial Martian environment and demonstrated the same activity that they would in their natural environment. That's from Jean-Pierre Paul de Vera, who presented that paper at the European Geosciences Union in April of 2012. Okay, let's then turn to curiosity. The principal investigator, Rogenzer, said that curiosity has already achieved its major scientific objective. Quote, habitability is in the bag, end quote. Unfortunately, for some strange unknown reason to me, he was referring to past habitability. Why not the present? Well, perhaps it's because some people still say there's no liquid water on Mars. Viking discovered liquid water on Mars when the temperature of the soil at its footpad, as the sun rose, the temperature rose but stopped at 0 degrees centigrade. Why? That's the fingerprint for ice melting into liquid water. In addition, there was an orbiting experiment on Viking called Mars Atmospheric Water Detector. It detected saturated atmosphere, saturated in water vapor down at the lower depths. If you've got saturation, it has to be in equilibrium with liquid water. There must be liquid water, maybe just moisture, but enough for bugs on the surface of Mars. Curiosity measured the atmospheric pressure at the site. 4 of these are shown for some 200 days. And the atmospheric pressure never fell below 6.11 pascals, which is the triple point for water. That means that liquid water would exist if the temperature were correct, which is between about 0 and 12 degrees on Mars. So that here is a confirming statement from Curiosity, followed by its measure of temperature. The temperature of the atmosphere and the temperature of the soil daily. And you can see each is frequently above freezing, especially the soil. With the pressure above the triple point of water and the temperature above freezing, there is liquid water. Thank you, Curiosity. But it went further and proved it with measuring the volatiles released at the John Klein site. Here they show the volatiles and discuss them. The important one, of course, is water. And they're talking about water coming out of hydrated minerals. Well, but when you get down here where it really counts, there is water vapor coming out at 0 and 10 and 20 and 30 degrees. The only source of that water vapor is liquid water in the soil sample. Now, the next we heard that the surface was strongly oxidizing. Here's a brief quote from a publication, and the important thing is, this is significant because it demonstrates that the environment was not violently oxidizing. Well, we demonstrated in 1981 that the environment of Mars was not highly oxidizing. Pat and I were team members of the IRIS experiment on Mariner 9, and I recalled that, and in 1981 I got Bill McGuire, who was a team member, to look up the data. He looked up the data and found out, yes, we had a window for hydrogen peroxide, and there was none there in the entire atmospheric column. Now, in addition, Curiosity shows that there are hydrocarbons, and there is chloromethane and dichloromethane. While there's been some statement that they might be contaminants, they rightly ran blanks, and the blanks are way below the subsequent tests. So it would be very strange to have a contaminant rise above the blank on a test run. Then it was stated that perhaps the chloromethane and dichloromethane were made when the soil was heated in the presence of perchlorate, which is present on the soil. If that were the case, you would also have to have CCl3 and CCl4. Carbon tetrachloride would have to be formed in such a process. It's not there. It's not there. Now, when we and Curiosity confirmed that the surface of Mars is not highly oxidizing, this creates a real problem. The Mars atmosphere is primarily CO2. CO2 is rapidly destroyed by ultraviolet light. Therefore, its replacement is required, since it's 95% of the current Martian atmosphere. Where is it coming from? It should long ago all have been destroyed. So, what had been said until now was that it was the strong oxidant on the surface of Mars that was taking the CO, which had been produced by the destruction of the CO2 by UV, and reconverting it to CO2. Without a strong oxidant, you're kind of hung on your own petard. On Earth, living organisms, together with volcanic action and the release of CO2 from movement of tectonic plates, perform the resupply of CO2. Very little can be expected on Mars from tectonic plates or volcanic activity. Supporting biology as the remaining answer. However, the issue of organics remains. It's the only barrier to acceptance of the LR results as life. Had organics been detected by Viking, life would have been proclaimed by everyone in 1976. So if organics are now found by Curiosity, doesn't that rescue the Viking label release experiment from the dustbin of history? Well, simple organics have, I've done that. Simple organics have been found, and the problem that's remaining is these are simple organics. If life is present, we should expect complex organics, just as on Earth. I believe, and I predict, that Curiosity either has or will detect complex organicities, biological organics, which I call sniffing the BO of life. Now, I've got Steely trapped here, and he can't say very much because he's under wraps, but I want to ask him this question. Can you, Steely, assure us that Curiosity has no data relative to organics in the samples it has analyzed that have not been reported to the public?
Gil, I can assure you that Martian meteorites contain organics. That's what my work has been. So there is organics on Mars that contain meteorites.
Well, but I'm addressing complex organics.
Complex organics are in the meteorites. I published this in
I'm not, of course, I'm looking for stuff in the soil arising from life. And that's what I would like to hear addressed. They have not yet reported on the liquid extraction of organic material, which is a major experiment yet to be performed, or as far as I know, it might have been performed but not reported.
The Curiosity team has reported everything it can at the moment through the peer review process, and we'll continue to update those as
Okay, that's a cautious remark. Thank you. What's the status of life?
Gil, look, I gave you organics, mate. They're in the meteorites.
Yeah, right. What's the status of life on Mars now? Well, we have the positive proof that the LR found living organisms. We now know the challenges to it are gone away, and the last one, I predict, will be will be the finding of complex organics. The failure of the Viking organic detector has long been acknowledged. That instrument couldn't find organics on Earth. After 37 futile years of trying to explain away the Mars LR results, no one has ever non-biologically reproduced the Viking LR test and control data, even in theory, let alone in the laboratory. That's a powerful statement. Secondly, no finding on Earth or Mars negates the labeled release results. Thirdly, no finding on Mars precludes extant life. No single finding or complex findings preclude extant life. And finally, Mars and Earth have been swapping soils that could have carried living microorganisms in viable freeze-dried form. You heard today about how seeds are preserved freeze-dried for thousands of years. Microorganisms can be preserved freeze-dried for millions of years, can make the trip between planets. So, I believe that the evidence is rather compelling. And Occam's razor agrees, and agrees with that ultimate authority, Sherlock Holmes, as A. Conan Doyle wrote, when you have eliminated the impossible, whatever remains, however improbable, must be the truth. And I'm not offering this as negative evidence, because everybody says, negative evidence doesn't count. What I'm saying is the positive evidence is very strong, and nobody has found anything to refute it. Now, what's the effect of Mars on of life on Mars on humans to Mars? The first thing we must do is determine possible pathogenesis. Even if we are the same life, if life on Mars came from Earth or vice versa, in the different environments, they could have evolved to be pathogenic to us. So we've got to find out about that. But in addition, life on Mars could be useful to humans to Mars. It might help them in food, it might brew a better beer. We have to study it carefully. But for the non-believers, I long ago proposed a variation of the LR, as I indicated earlier, which variation is favored by many people. It has been successfully tested on Earth by NASA, but it's always been rejected for flight. Every time I've offered it, it's been rejected. It's the chiral labeled release experiment. As many people know, organic compounds frequently come in twin forms, a so-called left-handed form and right-handed form. On Earth, all life is peculiarly adapted to using left-handed amino acids and producing left-handed amino acids, using right-handed carbohydrates and producing right-handed carbohydrates. We knew that at the time of Viking. So not to take a chance that Mars life used different chiral isomers than Earth life, we put them both in the same solution. We wanted to send them up in separate instruments, but weight and power allowances wouldn't permit it. So the response we got, we cannot be certain which isomer, if any, it came from. So the chiral LR experiment proposed is to send the experiment back, which is a good idea to check the technology, but to include the separate isomers in separate instruments or containers. If we got back from Mars that only the left-handed amino acid produced a response, the right-handed one did not, no one would deny that this confirms that we had found life on Viking. If, on the other hand, we get back that only the right-handed amino acid responded, that's amazing, because that tells us we are not related to Martian life. That's a new kind of life. So this experiment would begin comparative interplanetary biology. And I cannot understand why it has not been since. So my recommendations are, I would appoint a panel to review the Viking LR data in present light. It hasn't been reviewed since 1976 by an independent panel. It's the biggest bang for the vanishing buck. I believe that an objective review would decide, yes, we do have proof that the public health standard methods detected life on Mars. Next, fly the chiral experiment to Mars to confirm life and to determine possible relationship to Earth life and to look for possible pathogenicity. Now, yes, let's return a Mars sample, but only to the moon or to a space station lab for study. Let's not take a chance on bringing it to Earth. I think Penny agreed today that the possibility of pathogenicity is very remote, but we only got one Earth, and the risk cannot be taken. So, I conclude, and hope you will, we are not alone. Let's go and find our cousins on Mars. Thank you. Oh, I forgot. I want to acknowledge, I've already mentioned Pat Stratt. I want to acknowledge the health of my son, Dr. Ron Levin, who did the theoretical work showing that thermodynamically there must be liquid water on Mars, and for his complete support of me. Thank you.
The noosphere, the human creative phase of the development of the universe, has become and must continue to become its increasingly dominant form of organization. Here, we will look at evolution from the standpoint of what Russian scientist Vladimir Vernadsky called the biogenic migration of atoms.
From his researches in geological history, and through a struggle to find an accurate measure for biological time, Dana made the empirical generalization that evolution shows an indubitable direction of development.